Hi guys, nice to see you again. Welcome to Angel Science Sharing Time, and let's crack chemistry together. Please subscribe my channel and turn on the notification so you can watch my video as soon as they are posted. Also, don't forget to leave your comments below and like my video. Before we start today's topic, let's have a quick review for last lecture. Firstly, we introduced a concept, ionization energy, which means the energy required in order to remove electrons from an atom. Then we learned electronic configuration. There are 3 points to know: the maximum capacity of each shell, rule 2, and number of electrons in the outer shell. The last point is about valence shell and valence electrons. Also, we know the octet rule that have 8 electrons in the outer shell is the most stable condition. If you forget the above details, then I strongly recommend reviewing my last video. Now let's move on to today's topic, section 1.7, the Schrödinger model of the atom. In this section, we'll cover 4 points. Why not just using Bohr model? Quantum mechanics, the Schrödinger model, and corresponding electronic configurations. The first is why not just using Bohr model? We have 3 reasons. Firstly, when dealing with more than 1 electrons, Bohr model is no longer accurate. Also, Bohr model does not explain why maximum electron capacity in each shell is 2 times n squared. Lastly, it fails to explain why the 4th shell accepts 2 electrons before the 3rd shell is completely filled. Because of such limitations, famous scientist Erwin Schrödinger comes up with his Schrödinger model, and today we will study this superior model. Then in Schrödinger's model, he revealed the energy of electrons are actually quantized, which means they can only be specific amount instead of arbitrary values. Compared with Bohr's model, Schrödinger model on the right-hand side suggests electrons have wave-like properties, and they occupy a 3D space called orbital around the nucleus. Regarding the Schrödinger model, what we need to know is different from Bohr model. In each shell, there are subshells existing, and every subshell contains orbitals. For a single orbital, it can accept 2 electrons at most. This chart shows detailed structure of the Schrödinger model. There is 1 shell in the first shell. So this is the first shell, and this is the subshell of the first shell, which is 1s, and it contains 1 orbital. This orbital has a maximum capacity of 2 electrons. So the first shell can contain 2 electrons at most. As to the 4th shell, it is the most complicated in this chart. After summing all of the orbitals up, we know its capacity is 32 electrons. But what's inside the 4th shell? Like what this chart shows, it contains 4 subshells. Subshell 4s, 4p, 4d, and 4f. Subshells ending with s always contain 1 orbital. You can see for 4s there is only 1 orbital. It is the same for subshell 3s, 1 orbital. Subshell 2s, 1 orbital. And subshells ending with p always contain 3 orbitals. This is for 4p, for 3p, and for 2p. And subshells ending with d always contain 5 orbitals. It is the same for 3d as well. And subshells ending with f always contain 7 orbitals. So how many orbitals in each subshell is concluded in this table? If you have any questions, take a look at it and try your best to remember. There is an obvious pattern within this table, so it is not that hard to remember. Take a second look at it and try your best to memorize. It's really helpful. So, after summing up the capacity of orbitals in each subshell, we can finally get to know the total capacity of each shell. This is how Schrödinger model explains electron capacity of shells. Great. Now it's time to digest the most important point, how to arrange electrons with the Schrödinger model. Frankly speaking, it is a matter of filling electrons into orbitals. And there are 3 points to notice. Like Bohr model, we start with orbitals with lower energy. The detailed sequence when filling electrons is shown in this chart. This chart actually tells us which subshell fills first, and which goes the second, the third one, the fourth one, etc., etc., etc. You only need to follow the direction of the arrow, and you will get to know the sequence when filling the subshells. You guys need to remember it, so during exams, you can arrange electrons without watching it. The second is, for each orbital, it can only contain 2 electrons at most. We have introduced this point just now. Number 3, when filling electrons, we place one single electron into each orbital first, till all orbitals of the same energy level are half-filled. Then, we put a second electron into these half-filled orbitals. For example, in the subshell 2p, we place one electron in each of the 3 orbitals. After half-filling them, we put a second electron in each of the 3 orbitals. So this is like how people sit in a library. If you see there is a vacant table on current floor, generally you will sit beside it, instead of sitting next to other people, right? Unless there are attractive girls or boys around. But if there's no totally vacant table, you can only sit on an available seat, sharing the table with someone you don't know. With these points, we can write down electron configuration like this. Numbers on the upper right side of subshells represent how many electrons these subshells carry. In this example, we can see there are 6 electrons in the subshell 3p, 5 in subshell 3d, etc., etc. All good. Now let's take a question for practice. This question asks us how electrons are arranged for a copper atom. One thing interesting is among all the elements, copper and chromium are 2 exceptions, because their electron configurations are unusual. For a copper atom, we know it has 29 electrons. So we start from the subshell of the lowest energy, 1s, and fill it with 2 electrons. Here, I fill the subshell 1s with 2 electrons. Now I am using blue arrows to represent electrons. And don't worry, the reason why they are heading to opposite directions is not required at high school level. Using the same method, we continue filling 2s. For 2p, there are 3 orbitals, so we fill each of them with 1 electron at first. 1 for each orbital. And then fill each of them with a second electron. Be careful with the sequence because if you fill electrons in another way, you will get different results. We can keep doing this until subshell 3d. So now I fill subshell 3s and then 3p. Normally, because 4s is of lower energy, it should accept 2 electrons at first and leave the last 9 electrons to 3d. But in this case, having 3d totally full is more stable. So here we transfer 1 electron from 4s to 3d. We only leave 1 electron to 4s. And then we leave the last 10 electrons all to subshell 3d. Firstly, we half fill them, and then we finish filling. This red arrow means that it is different. because normally we will not have it in substrate 3D, we will put it in 4S, but in order to make it more stable, we transfer it from 4S to 3D. That's why it's highlighted with a different color. And we have the overall configuration as this. The golden one shows clearly that there are 10 electrons in 3D and only 1 in 4S, instead of the other scenario. As for chromium, it is of the same reason. So we have all orbitals of 3D half-filled, and leave only 1 electron to 4S. Instead of having 4 electrons in 3D and 2 in 4S, we transfer 1 electron from 4S to 3D, so that we have 5 in 3D and 1 in 4S. This is more stable, because all of the orbitals in 3D are half-filled. They're always more stable than the other scenario. Apart from copper and chromium, all other elements follow the ordinary electron configuration. And I only list these 2 exceptions here to draw your attention. Great! Flashback time! Today we unlock section 1.7, the Schrödinger model of the atom, and successfully cleared the final stage. So chapter 1 has been done. Congratulations! In specific, we introduced why cannot keep using Bohr model, the concept of quantum, the Schrödinger model, and how to use it in electron configuration. Now we level up to level 8. I hope you do gain a lot from my lectures. Every time when drafting videos, I spend a lot of time filtering out unimportant contents and try my best to present the core contents in a reader-friendly way so you can understand easily. If you have not left your comments, please do so right now to help me make this channel better. Also, feel free to leave your questions and I will answer you. Don't forget to like this video and share it. More importantly, please subscribe my channel and turn on the notification so you can watch my video first time. Good luck guys and have a good day. Bye!